We ended last video talking about end behavior, so knowing if it starts up or starts down, knowing if it ends up or ends down. But we still have no idea what's happening in between how it begins and how it ends. So now let's talk about what happens kind of in the middle of that. And we're going to be talking about x-intercepts and factors, which go together. It says the number a is said to be the factor of a polynomial f of x if f of a equals 0. And this is actually going to be a theorem that we go over in the last lesson, lesson 9 of this module. Thus, the point a comma 0 denotes the x-intercept, which is also known as a 0. Those mean the exact same thing. So the big part, the x-intercept a comma 0 of a polynomial corresponds to the factor x minus a of a polynomial. So notice we have a positive a here, and when we put that in, that's a negative a. When we factor, we use factoring with solving quadratics. Once you have those factors, what would we do? We would take what was in those, set them equal to 0. So if I subtract that a over, we would get x equals a, right? So it turns positive once you set it equal to 0 and solve it. So let's work between going back and forth between, honestly, our ordered pairs, our x-intercept, and our factor right here. But not really back and forth, but just kind of all in one. So for example, if I have h of 9 equals 0, what is the point, the ordered pair that this is using in that graph? Well, if you remember, what's in parentheses is my x, and what your function equals is your y. So this point on the graph would be 9, 0. So what is the corresponding x-intercept? If you were to graph that, we would get that x equals 9. X equals my x coordinate here. And what does that look like when you put it as a factor? What is the corresponding factor associated to the x-intercept? You want to change that sign right here. So now this is x minus 9. Right? If you set that equal to 0, you add the 9 over and we get x equals 9. Okay, all three of these things are representing the exact same thing, the exact same point on this graph. Pause the video and see if you can fill out this table. Okay, I hope you had time to pause the video. Let's check your answers here. At this point, if I have p of negative 12 equals 0, that is negative 12 comma 0. The corresponding x-intercept of the graph is x equals negative 12, which is whatever that x coordinate is. And then the corresponding factor associated with this x-intercept, change that sign. So this is x plus 12. If you set this equal to 0, you subtract your 12 over, and you're going to get x equals negative 12. So now let's kind of use that with this graph. Instead of them telling us the point, now we have to go and find the points from this graph. This says use the graph below of the polynomial function f of x. Part A is to solve when f of x equals 0. F of x is another name for y. So we want to know, when does our y equal 0? Well, when does this y right here equal 0? On this number line here, it's right here in the middle. It's at the origin. So we're talking about our x-intercepts. This is another way of saying, what are the x-intercepts? So what are my x-intercepts here? Well, we have x equals negative 2, 1, and 2. So now find the factorization of f of x. So now I have what x equals. Now we need to put it into factored form. So we're going to have f of x equals, change that sign, so that will be x plus 2. change this sign, x minus 1, and change this sign, x minus 2.